Good afternoon, everyone. I hope you all are well. And uh, have you taken your lunch, everyone? So, today we will start a next lecture or the fifth lecture of the KTG and Thermody. In the previous lecture, we were discussing about adiabatic process. The last topic we were discussing about was adiabatic process. In the meantime, we were discussing the work done in the isothermal process. We have considered some numerical. And one thing that is very important, you may say that this is going to be an announcement type of thing that as your board, as your final exams are approaching, so what we have decided that in every subject, uh, we will deal more with the CBSE pattern. The content will be inclined towards the CBSE pattern, so it will be more like your CBSE classes for until your exams. So try to be more attentive in that situation because as the CBSE exams are going to start, so that's the decision that we have taken in considering your exams. So be focused because from today onwards, your the syllabus we are focusing on is entirely based on your CBSE curriculum, your NCRT books, your other reference books. So be attentive. So that's a kind of information or the announcement you can say, and please share it with everyone in your class or uh, the number of students you can share that will be better. Okay. So today we are going to start fifth lecture. What's in this lecture and what's more important? First of all, we will discuss work done in the adiabatic process. That's again a very important derivation for your examination, for your CBSE examination, the derivation part. Then we will discuss about slopes of adiabatic and isothermal process. These slopes actually they it might come in the 1 mark question as an a multiple choice question. There will be a concept test. Then we will discuss about heat engine and the efficiency of heat engine. There will be one more concept test there. So that's all we are going to discuss in today's class. We will deal more with numerical problems or the conceptual problems in the weekend class. So that's the idea for the further classes. Okay. So first of all, first law of thermodynamics, if we apply to the adiabatic process, what will happen? Now listen to me very carefully for each and every point actually. First law of thermodynamics says Q is equals to delta U plus W. Now for the adiabatic process, what's the most important thing? That heat transfer is zero. That means Q is going to be zero because of the adiabatic process. So you can say that delta U is equals to negative of W. Let it be equation number one. The announcement actually, the student that has joined, I have announced actually that from today onwards, the curriculum that we are teaching here, or all the subject teachers teaching, will be more inclined towards your CBSE exam as your board exams are approaching. So try to share the information with your your classmates actually, so that more and more students can join because these classes are spatially oriented towards your CBSE curriculum for your examination point of view. Now, delta U is equals to negative of work done. Now, there might be situation like you should understand this is going to be a punchline and it directly being asked in your CBSE exam. Like for expansion, what we have seen that during the expansion, work done is positive. During the expansion, work done is what? Work done is positive. If work done is positive, then you can see that delta U will be negative. From where you can see that from equation 1, you can see that if W is positive, delta U is negative. What is the significance of delta U negative? That means the significance of this line is the gas will, delta U negative means temperature will fall. Temperature will fall. Fall means decrease. So what does it mean? The gas will cool down in adiabatic expansion. When the gases are expanded adiabatically, like you can feel that when balloon, which is opened at, when you blow a balloon and you open it at the end, the air coming out of it feels a little bit of on colder side because the expansion was adiabatic kind of expansion. In the same way, if you can see for compression, if you compress, for compression, you can see work done is going to be negative. If work done is negative, there is already a negative sign, then delta U will become positive. So what is the conclusion? Delta U will become positive, and the rest you can write it by your own. That what is going to be the punchline? The gas will heat up in adiabatic compression. That's another very good thing. So, what are the two conclusions that you can draw? In adiabatic expansion, gas will cool down. In adiabatic compression, gas will heat up or its temperature will increase. So, try to remember these two punchlines, 1 and 2. They can be asked directly in the examination. Okay, moving further. I think everything is clear. Work done in adiabatic process. Again, this is again an important thing. Work done in adiabatic process means, let's suppose there is a thermodynamic system in which volume is changing from V1 to V2. Whenever you need to calculate the work done, what you should do, work done is always going to be equals to integration PdV. That's what we have learned. Work done is always equals to PdV from initial volume, that is V1, to final volume, that is V2. Okay. Now we need to place the value of P. P is the pressure. For adiabatic process, what we have learned, I'm discussing it here. For adiabatic process, we know that P into V raised to the power gamma is equals to constant. Or you can write the constant as, suppose I'm writing the constant as K. Is it clear? So P into V raised to the power gamma is what? K. Here gamma is what? Gamma is adiabatic constant, which is Cp over Cv. That's also been discussed in the previous class. Now, one more thing that you should know, that if we calculate P from here, then P will be K over V raised to the power gamma. Let's suppose it is equation number 1. Now we got the value of P. One more thing that you can write. Now replace the value of P here. Then work done will be integration. P can be written as K over V raised to the power gamma. K is a constant. It can be taken out. So it will remain 1 over V raised to the power gamma dV. Now you need to integrate it from where? From V1 to V2. So I am integrating it. W is equals to K is already here, which is a constant. If I integrate it, what we will get? V raised to the power minus gamma plus 1 divided by minus gamma plus 1. Is it clear that integration part is clear? V raised to power gamma will move in the numerator side and it will become V raised to power minus gamma. From where to where? From V1 to V2. Now you can just place the values, place the limits K over minus gamma plus 1 V2 raised to the power minus gamma plus 1 minus lower limit, that is V1 raised to the power minus gamma plus 1. Till now, if you have any doubt, you can ask me. Till now, up till this point, if you have a doubt, you can ask me. I am reading your chat box. If no, then we can move further. Okay. Okay. So we have placed the limits, upper limit minus lower limit. You know the concept of integration and the limit putting. Now again, in the next step, if I say this K is a constant and we can transfer it inside. So now what is the value of K? You know that K is a constant which is P into V raised to the power gamma. If I say P V raised to power gamma is constant, that it can also be written as P1 V1 raised to the power gamma is equals to P2 V2 raised to the power gamma is equals to constant. Because at every state, at every state of the thermodynamic process, this ratio, this term is constant. So I can write it as that. Now I will multiply K inside. I will multiply K inside the bracket and place the value of K from this equation. So work done will be 1 over minus gamma plus 1. I am multiplying K. And what is the value of K? K has two values. I will put the value when there is V2, I will put the value related to V2. So what it will be? P2 V2 raised to the power gamma. This is the value of K into V2 raised to the power minus gamma plus 1. This is complete term minus again multiplied with K. V1 is already there, so I will put the value related to V1, that is P1 V1 power gamma. So what will be it become? P1 V1 raised to the power gamma into V1 raised to the power minus gamma plus 1. I hope this step is clear. If this step is clear, then we are done with the derivation part. And it's an important derivation. Most of the time, CBSE ask the question or in your 11th board exam actually. So if I write it further, work done will be 1 over minus gamma plus 1. You can see if you can multiply these two terms, you will get P2 V2 minus P1 V1. I think you can, in multiplication, power adds up. So power add, if you add, the gamma and minus gamma will cancel out. So the complete work done will be, I am transferring this negative to the inside by taking common. So it will become P1 V1 minus P2 V2 divided by gamma minus 1. This is the work done in the adiabatic process. This is what? This is the work done in the adiabatic process. I hope this point is clear. Work done derivation, from work done, from this derivation, what you can learn actually. In the previous class, we also performed a numerical, we also solved a numerical in which value of P was replaced. So from here, you can learn this concept that value of P should be replaced and how it can be replaced using the equations. So that's what we have learned. Now again, you also know that from ideal gas equation that PV is equals to nRT. PV is equals to nRT. So this work done can also be written as P1 V1 is nRT1 minus nRT2 divided by gamma minus 1. Can anyone reply in the chat box that what is gamma here? What is gamma here? And what is the value of gamma for monoatomic gas? Can anyone answer? First, what is gamma called? What is its ratio? Can anyone answer? What is Cp? What is Cv? Do you remember these things from the previous class? So this is the work done in the adiabatic process. Okay. So for the point of view of your CBSE exam, what is more important for you? The two processes are very important for you. One is isothermal process and another is adiabatic process. What's more important in isothermal process? The work done, the derivation of work done in isothermal process is very important. So try to keep it in mind and try to practice it a lot because the numerical also came from that part. Okay. So I'm moving further. This is again a 1 mark objective question that is going to be asked in your exam or in a very short question of 2 marks. Slope of adiabatic process. The result you should remember always. Okay. I'm trying to solve it out. For example, what we have seen, this is a PV diagram of adiabatic process like this. The arrow might be downward direction, might be in upward direction. So I am not going to discuss that arrow right now. We will discuss it later. So slope is what? Slope is what? Tangent at any point. This is the slope that we are going to discuss. The graph is between P and V. So slope of adiabatic process is nothing but dP over dV. This is the slope, dP over dV. So we will calculate this dP over dV. For that, what you know that you should know the differentiation actually, how to differentiate things in the U into V form. Okay. We know that P into V raised to the power gamma is equals to constant. And you want to calculate dP over dV. So first thing that should come in your mind that we need to differentiate this equation. And if I differentiate it, let's say differentiating with respect to V, with respect to V. So we are differentiating it. Now P and V are interrelated. These two things depend on each other. Or you can say P depends on volume. So while differentiating it will be a function of U into V type. I think you know the differentiation of U into V type. If you don't know, I can mention it for you. For example, d over dx U into V is what? This is first function, this is second function, and both function depends on x. Then, first of all, write the first function U and differentiate the second function plus write the second function as it is and differentiate the first function. I think it is clear to you. What we are going to do, write down the first function. Okay, so I'm differentiating it. This is our first function. This is our second function. So write down the first function as it is, that is P, into differentiate our gamma, it will become gamma into V raised to the power gamma minus 1. What is differentiation of x ki power n? X raised to the power n. That is nx minus 1. Similarly, gamma V raised to power gamma minus 1. This is the first part, this one. Now plus, this time write the second function as it is into differentiation of first, that is dp over dv is equals to constant. Constant, differentiation of constant is what? 0. I think clear. Now we can transfer the things here. First of all, look at that. Is this step clear to you, everyone? If this step is clear, only then we will proceed. Yeah. Okay. So we need to calculate dp over dv. So it will be v raised to the power gamma dp over dv is equals to, I will transfer this term here, negative of p into gamma into v raised to the power gamma minus 1. So dp over dv will be negative of gamma p divided by v. If you transfer v raised power gamma here, it will become p over v. So this is the slope of adiabatic process. The question that actually come in your mind is the question related to the slopes of adiabatic and isothermal process. They ask the relative slope of the adiabatic and isothermal process, and that's a very common question for CBSE exam. So this is the slope of adiabatic process. You need to remember that gamma times P over V. Again, moving further. Slope of isothermal process. This is the same thing. The PV graph of isothermal process also looks like the same. This is P, this is V, and graph of PV will also look like the adiabatic process. But the thing is that for adiabatic process, it follows P into V equals to constant. So I am differentiating it very quickly. Differentiating with respect to volume. What we will get if I differentiate it, first function as it is, differentiation of second function will be 1. If you differentiate V with respect to V, it will be 1 plus second function as it is, differentiation of first, that is dp over dv, differentiation of constant is 0. I think the point is clear. If you can differentiate the function u into v, then you can easily get that. Now, dp over dv, or you can say v dp over dv is equals to negative of p, or you will say dp over dv is what? Minus p over v. So now we have both the slopes. Slope of adiabatic and slope of isothermal process. What can you conclude from these slopes? You can see that if you compare the two results, slope of isothermal process is only minus p by v, and slope of adiabatic process is gamma times p by v. Can you conclude that? A conclusion thing, the punchline, that slope of adiabatic process is equals to gamma times slope of isothermal process. Can you see that? This is going to be our punchline, that which has more slope. You will say adiabatic process has more slope. You will say adiabatic process has more slope as compared to isothermal process. Now, the question that should come in your mind, or that will come in your exam, that, for example, there is a graph mentioned on your screen. On your question paper, there is a graph given, and you need to identify out of these two graphs which may represent isothermal process and which may represent adiabatic process. That's the thing that you should answer. This is the question that is asked from you. Can anyone answer? That out of these two graphs, which graph is representing, for example, let's suppose this is graph number 1, this is graph number 2. Which graph is representing isothermal process and which graph is representing adiabatic process? Okay. So there are various ways to solve it out. I am telling you a very simple way. Whenever you need to find the slope, you should, first thing that should come in your mind, that is dp over dv. That is dp over dv. Now have a look at the graph. Can you see that for both the graphs, change in volume is same? Let's suppose from V1 to V2. In both the graph, change in volume is same. Then you can see that dV is same. This is same. Is it clear? Now, if dV is same, and what we have learned, that adiabatic graph or adiabatic process has higher slope. Adiabatic process has high slope or more slope, you can say. If adiabatic process has more slope, that means for adiabatic process, dP should be more. More for adiabatic. What is the meaning of dP? dP means change in pressure. So change in pressure should be more in adiabatic process. I think you are getting the point. dV is same for both the process 1 and process 2. But adiabatic process has more slope. For that, the change in pressure should be more. Now have a look at that. If you can see, the change in pressure thing, for process 1, change in pressure is this one. This is the process 1. And for process 2, change in pressure is from there. This is for process 2. So in which case pressure is changing more? You will say in second case pressure is changing more. So if in second case pressure is changing more, then the second process will be adiabatic. So the second process will be adiabatic. And first will be isothermal. So what's the conclusion? The main thing, the concept is on your screen, that what is the concept I am using. But some student might learn these things or might remember these things if whenever we are talking about expansion, Then the graph above represents isothermal and the graph below represents adiabatic. You can either remember the things or you can apply the concept. It's up to you. If you have any doubt, you can ask me. And if everything is clear, then tell me which is process one. Let's suppose this is process one and this is process two, which is adiabatic and which is isothermal. Meant fast. Sorry. I'm sorry. Okay. You can answer in the chat box. This is a very famous question. Concept is delivered. What you need to answer that out of this process one and process two, which is isothermal and which is adiabatic. Again, you can check it with the slope. Slope is what? dp over dv. I am delivering the concept again. You can again see that from this point to this point, the change in volume is same. Change in volume is same for both the processes. So dv is same. Now for adiabatic process, what should it should be? dp should be more for adiabatic. I think the line is again clear now. dp should be more for adiabatic. Clear up till this point. I think if dp is more, then in which case change in pressure is more. For process one, you can see that pressure is changing from this point to this point, or you can see from this point to this point. So change in pressure is more for process one. That means process one is what? Adiabatic. And process two is what? Isothermal. Now, you should remember these things whenever there is expansion, then isothermal curve is above the adiabatic curve. And whenever there is a compression thing, then adiabatic curve is above the isothermal curve. You should remember these things. I hope the thing is clear. Okay. One more question that I am going to take here. That's again a very basic fundamental question that may come in your CBSE exam in the multiple, that 18 questions that are going to become in your multiple choice questions. So in that case, try to solve it out. And this question will take hardly 45 seconds to solve. So try to solve it out. Give yourself a try. And just don't sit. Try to attempt the question. That's the main thing. That's how you learn. JNVRR, Warangal, uh, JNV, Beed. Okay. And there is one very difficult name to pronounce. Everyone give it a try. Let's try to solve it out. Okay, someone got the answer. JNV Aurangabad. Okay, very good. JNV Aurangabad. Okay, so I am solving it out. And if you are solving, then solve it with me. Okay. What are they saying? Adiabatic process at room temperature, the relation between temperature and volume in the process is given like that. Okay. So what we know that about adiabatic process, we know that P into V raised to the power gamma is equals to constant. Now P into V raised to power gamma into constant, but the relation that is given is in terms of temperature and volume. The relation is given in terms of temperature and volume, so we need to transform it again. And for that, what we know that I am writing it here. PV is equals to nRT. That's what we know. So can you see that we need to remove this P? So I am removing this P, and P can be replaced by nRT over V. Place this value of P. nRT divided by V into V raised to the power gamma is equals to constant. Clear? Can you see that N and R both are constant? So it will become T into V raised to the power gamma minus 1 is equals to constant. Clear? That means in the equation, the term X is nothing but gamma minus 1. So you can see that X is equals to gamma minus 1. We can compare these equations. Na? PV raised power X for the adiabatic process, the equation is given. And what we have calculated, PV raised power gamma minus 1 equals to constant. So X is what? Gamma minus 1. If we know that X, then we need to put the value of gamma to calculate X. Then what is the value of gamma? We have derived a relation for that. Can you remember? What is the value of gamma for diatomic gas? I think gamma is equals to, if you don't know, I will tell you gamma is equals to 1 plus 2 by F. And for diatomic gas, F is what? 5. That means 1 plus 2 by 5. That is 7 by 5. That's what gamma is. So X is what? 7 by 5 minus 1. That is 2 by 5. So which option is correct? Option B is correct here. What is F? Degree of freedom. What is F? Degree of freedom. And for diatomic gas, diatomic ideal gas, degree of freedom is what? 5. And this is the formula for gamma that we have derived in the previous class, in the yesterday's class. You need to remember this formula. Moving further. Now, is this question clear to you? Everyone? Now moving further. Heat engines. Now, this is the most of, you can say that every time there might be a question in your exam about heat engine or Carnot engine. Heat engine or Carnot engine, out of these two, one engine might come or definitely come in the examination of your in your final examination of CBSE class. So what is heat engine? Heat engine is nothing but it is a device which converts the heat energy into some form of mechanical work, which converts heat energy into some form of mechanical work, like you can say steam engines. like you can say steam engines, and you can say the petrol engines. Like now, these engines, what they do, they take heat and convert it into mechanical work. So what is heat engine? Heat engine are the devices that convert heat energy into mechanical work. I think this point is clear. What they do, how they work, what is their working principle. So you can see that it takes some heat from the bodies at higher temperature, converts a part of it into mechanical work, and rejects the rest to body at lower temperature. This language might be confusing for some of you, but I will tell you, I will explain everything to you in the next slide. So first thing that you should know or you should remember, that whenever a heat engine works, it works in a cyclic process. That's the most important line that you should remember for the rest of the class. Heat engine operates in cyclic process. And what is cyclic process? We have already discussed. So there is no need to discuss about it right now. So heat engine operates in cyclic process. This is the punchline. Now, have a look at this diagram. The line that is mentioned earlier is explained in this diagram. What's happening here? What is heat engine? What is the principle? That there is a high temperature body and there is a low temperature body. What is high temperature body is called source and low temperature body is called sink. One thing is clear. The working substance, I will describe it. The working substance takes heat, or you can say heat engine takes heat from the source. Like suppose it has taken Q1 heat from the source and performs some work W and rejects some heat Q2 to the sink. In real life, like your bike engine, you can say the heat is generated inside the engine by the combustion of the fuel. So the combustion of the fuel, you can say, is required because of the high temperature source. Whenever a engine is performing work, whenever for any kind of engine, you need a high temperature source, and that high temperature source is achieved by the combustion of fuel inside the engine. So you can relate that if you can touch the engine, don't ever try to touch it, but with some precautions, if you can touch the engine of your bike or car, then you will feel it's very, very, very hot. Why it's very hot? Because it has become a source of heat by the combustion of the fuel inside it. And after performing the work, the extra heat is rejected from the silencer. You would say the exhaust pipe, which is generally commonly known as silencer pipe, or you can say it is exhaust pipe. So in real life, these are the phenomena. From a high temperature body, some heat is extracted, some work is performed, and the remaining heat is rejected to the sink. In our bike, what is sink? The surrounding is the sink. In our bike or car, what is the sink? Sink is our surrounding. Clear? Now, what are the main components of heat engine? You can see main components are, one component is source, another component is sink, and another component who is performing the work, that is working substance. Three components of the heat engine are source. What source can do? What is source? Source is nothing but a high temperature body. You can say reservoir. If you don't know, reservoir is something that keeps its temperature constant. Or you can say a body with high temperature from which any amount of heat can be extracted. Its temperature will not change. Its temperature will remain constant. That is what source is. In real life engines, the constant source of heat is created by the constant combustion of the fuel. I think source is clear. Source is nothing but high temperature source, high temperature body, nothing else. Then there comes working substance. Working substance is what? Which takes the heat. Substance which receives the heat from and performs some work. जो हीट रिसीव कर रहा है और कुछ वर्क परफॉर्म कर रहा है. लाइक एग्जाम्पल, वाटर इज द वर्किंग सब्सटेंस इन स्टीम इंजन. वाटर इज द वर्किंग सब्सटेंस जो हीट लेता है, जिसकी वजह से हीट जनरेट होती है, वो आगे फॉरवर्ड करता है. इट्स एवरीथिंग इज डन बाय वर्किंग सब्सटेंस. देन देयर कम्स द सिंक. व्हाट इज सिंक? ए लो टेम्परेचर बॉडी. व्हाट इज सिंक? ए लो टेम्परेचर बॉडी to which any amount of heat can be given. I think this point is clear. What are the main components of heat engine? Source, sink, and working substance. Source is a high temperature body, sink is a low temperature body. Clear? Moving further. Efficiency of heat engines. So we have 2-3 minutes left. I think time is up already, but we will take 2 or 3 minutes. Whenever efficiency, they are talking about efficiency. Efficiency is denoted by eta. Denoted by eta. This is known as eta. So whenever someone is asking about efficiency, it is always, this is general truth. Output over input. Output over input. This is always the case. Now, what I'm saying that in our heat engine, you can see that this is a high temperature source. This is working substance. This is sink. That's how the diagram was drawn, and you should draw that. This is source. I'm drawing it very quickly. This is sink, and here some work is performed. Let's suppose Q1 heat is taken from the source and Q2 heat is rejected, and some work W is performed. From the first law of thermodynamics, you can see that W is equals to Q1 minus Q2. W is equals to Q1 minus Q2. Now what I am saying, according to you, what is the output here? What is the output? You will say that work will be our output. The work we get is our output. Then what is our input? You will say the heat that is taken from the source is our input. Am I right or wrong? Efficiency is always the ratio of output over input in every situation. It's a general term. So you need to identify which is output, which is input. So the work you are getting from the engine is your output, and the heat you are receiving from the source is your input. So what is the efficiency then? Efficiency will become W over input is what? Q1. W over Q1. So efficiency you can write again. W is what? Work done. And work done is what? Q1 minus Q2 divided by Q1. Eta can be again written as 1 minus Q2 by Q1. I think the thing is clear. So you know about efficiency now. So I think heat engine is done. In the next class, we will discuss about second law of thermodynamics, and we will discuss about Carnot engine as well. That's another important topic for your CBSE exam. So one more time, I am announcing the things here that from today onwards, all of your classes will be more inclined towards your CBSE exams. Till then, try studying, keep studying. I am ending the session now. Bye everyone. If you